So we are still in the power distribution of amplitude modulated signals. So let's talk about the power spectrum. So only the sidebands have the desired information. The carrier serves as a vehicle for this information and allows it to be sent and retrieved more easily, but carrier power alone is wasted power. So as we have talked about modulation in earlier discussions, we modulate at a higher frequency. So si carrier gagamitin lang natin para maipadala yung ating information signal. So, if yung transmitted power mo only has the carrier power, then wasted power lang yon because the sidebands, as stated here, have the desired information. So, nasa kanila yung information na ipapadala mo. Si sideband yung information, si carrier yung ating vehicle. So, eto, transportation lang siya. Transportation lang si carrier power para maipadala natin yung signal power natin to the receiver. So, the carrier serves as a vehicle, as I have said, for this information and allows it to be sent and retrieved more easily. So, for ease, gumagamit tayo ng carrier signal or the carrier power para maipadala yung ating information signal. So, at 100% modulation, okay, at 100% modulation, the efficiency of the transmission is equal to 33%. So, yung 33% na to is in the sidebands. Okay? So, yung efficiency na yon o yung 33% na yon na power na yon is contained in the sideband. So, if you're going to compute for the wasted power during transmission at 100% modulation, that is equal to 67%. Okay, so ito yung total wasted power natin. Ito yung efficiency or ito yung parang desired signal, yung signal na pinadala mo mismo. That is only 33% of the transmitted signal. So, compromise for this one. So, ang laki ng wasted power natin for this one. So, compromise na lang dito, inefficient use of power, of course. Inefficient use of power, but ease of modulation and demodulation. So, ito yung compromise. Easier naman yung modulation and demodulation natin. That's why they prefer a 100% modulation kahit na inefficient use of power or marami yung nawi-waste na power natin during transmission. Kasi in modulation and demodulation niya, in retrieving or in transmitting and retrieving the information signal, mas mapapadali naman. Okay? So, channel interference. So, of course, meron pa rin tayong channel interference. Hindi yan mawawala. So, to remove or to reduce channel interference, the station may reduce the bandwidth of its transmitted signal, lower its transmission power, change the radiation power of its antenna, and go off the air. So we have the different types of your AM transmission. We have your double sideband full carrier or DSBFC, double sideband suppressed carrier or DSBSC, single sideband full carrier SSBFC, single sideband suppressed carrier SSBSC, and single sideband reduced carrier or the SSBRC. So let us try to solve problems. So a single sideband SSB signal contains 1 kilowatt which is modulated at 80%. How much power is contained in the sideband and how much in the carrier frequency? So una, sulat muna natin yung mga given parameters natin. Okay? So, given tayo ng total power which is 1 kilowatt and then modulation index which is equal to 80% or 0.8 and then it is asking us to find how much power is contained in a sideband and in the carrier frequency. So, yung sideband natin, since single sideband siya, isa lang. So, it's either si lower sideband or si upper sideband. Depende kung ano yung gusto mong gamitin since they are equal naman. And then, we are also looking for the carrier power. So, solution natin dito is, since ito ay single sideband, the total power formula will be equal to PC plus PUSB. So, si upper sideband na lang yung gamitin natin. So, this is the formula or the equation for the total power of the single sideband signal transmission. Now, ano yung formula ni PC and ano yung formula ni PUSB na pwede nating i-substitute? So, PT, since we are looking for PC pala, so i-retain natin si PC, ano? So, PC plus, what about si PUSB? Hanap tayo ng formula ni upper sideband power which contains si carrier power. So, if you recall in our discussion in the previous video, we have a formula for the sideband which is equal to m squared PC all over 4. So, we can actually use this one. And then, simplify tayo to get an equation for PC. So, PT is equal to, so kunin natin yung LCD niya. So, that will be equal to 4PC plus m squared PC. So, cross-multiply natin si 4 to the other side. This will be equal to 4PT. And then the right side will have an equation of 4PC plus m squared PC. So, we can now factor out si PC here. Okay? So, that will be equal to 4PT equal to PC. Factor out natin si PC and we will be left with 4 plus m squared. And then, we can cross-multiply si 4 plus m squared dito and we will be left with PC. So, the formula for PC now will be equal to 4PT divided by 4 plus m squared. So, we can now solve for the carrier power. So, by substituting this given parameters dito sa ating manipulated equation or the new working equation, we will have 4 times 1 kilowatt, okay, 1 kilowatt divided by 4 plus si m natin, that is 0.8 squared. So, PC now will be equal to 862.0690 watts. So, this is the wasted power lang. Okay? How about yung ating information signal? So, that is contained in the sideband. So, we are going to solve for PLSB, which is also equal to PUSB, and have the formula m squared PC all over 4. So, PUSB equal to PLSB is equal to, okay, so if we are going to substitute the given values, we have 0.8 squared multiplied by the computed carrier power, that is 862.0690 watts divided by 4. And the power in the sideband is equal to 137.931 watts. So, ito na ngayon yung ating power in the sideband, in one of the sidebands, and power in the carrier. Okay, so let's have another example. A 400-watt carrier is modulated to a depth of 75%. Calculate the power in the modulated wave in the following form of AM. So, A, that is DSBFC or the double sideband full carrier. And the next one is SSBSC, or the single sideband suppressed carrier. Okay, so let's solve muna si A, or sulat muna natin yung mga given parameters natin that will be equal to 400 watt carrier is modulated to a depth of 75%. So yung M natin is 75%, which is equal to 0.75, and yung carrier power natin, PC, is equal to 400 watts. So what is the total power in the SBFC? So letter A, PT at DSB. Okay, so double sideband full carrier. Since double sideband to and full carrier siya, yung gagamitin natin na formula will be PC times 1 plus M squared over 2. Okay, so let's substitute the given parameters na lang dito sa ating formula. That is 400 times 1 plus 0.75 squared all over 2. Then the total power at DSBFC AM transmission is equal to 512.5 watts. Okay. For letter B, okay, we have single sideband suppressed carrier. So PT at SSBSC. So what do we mean by suppressed carrier? So kapag na-suppress si carrier natin, ibig sabihin wala tayong carrier. Okay? So, no carrier, no PC, and single sideband lang siya. So, it's either si PLSB or si PUSB. And the formula for this one is equal to your M squared PC all over 4. Okay, so let's plug in the values. So, this is equal to, sige, gamitin na lang natin si PUSB. That is equal to 0.75 squared times the PC, that is 400 divided by 4. So, the power in the sideband, okay, so it's either LSB or USB to ha, is equal to 56.25 watts. So, that is how you compute for the different power distribution in the different types of AM transmission.